Okay, so here, let's work on this problem. This is the Go programming problem. I want to give you more exercise before you go to do the homework. So please read the problem statement first. Okay, so some hints. Start from the decision variables. Figure out what this CFO is trying to decide. Okay. And write out any hard constraint that should not be violated. For example, they only have this available 1.2 million. It's pretty clear that because the total budget requested exceed this amount, not all of them can be satisfied. So that means this 1.2 is a hard constraint. Okay. He cannot allocate more than what he has. Okay, then you need to decide what are those goals. Each of those departments have their request. Okay. So, and when we talk about, so what are those goals? Goals represent the things that are desirable. And in this case, what are the desirable things when this CFO is trying to allocate those money? So for those 5 requests, the CEO can allocate more than that or less than that. Probably it won't be more than that, but in your model you can include both. And at least 70% here represents a hard constraint. Because it says you want to make sure that each department receives at least 70%. And remember, at the end of a Go programming summary, we said some of those hard constraints can be added. Okay, so first let me ask you, what are the decision variables? X1 through for I goes from 1 to 5, right? Represents the amount of money to allocate to department I. Okay, so always start from what's the decision? Okay, and then we have some, and for the Go programming problems, we know that we don't start from objective. We first do the constraints, right? And we start from those hard constraints that need to be satisfied. Okay, we talk about this one being a hard constraint. Okay, so that means the sum of your xi need to be 1.2 million. Okay, and we also mentioned that there will be another hard constraint. At least 70% of the required amount should be met. So that means another 5 constraints here. Okay, so that's xi, greater than or equal to this 7% times the required amount. Okay, I won't write that. Actually, I'm going to ask you guys to post your solution to the Moodle forum later. Same as all the online students. Okay, so that's a hard constraint. And then we said, okay, the goals represent the desirable things to do. For this CFO, besides those 2 hard constraints, it's always desirable to get as close as possible to all the requests, right? In this problem, it's not really obvious. Say those are the goal, but you can kind of tell. Okay, so Go 1. So you have your Go 1, Go 2, Go 3, Go 4, and Go 5, which represent the 5 soft constraints you will need. So you will need 1, 2, 3, 4, 5 soft constraints here using the decision variable and the deviations. So the plus minus the d's. Okay. With that we check. Okay. What do those things give us? Consider requests for Department 2 twice as important as those from Department 4-5, and requests from Department 1 to be twice as important as those from Department 2 to 3. With this, you can get the weight. Okay. Remember the example I just told? Okay, so with this, you can get the weight. Okay. Then you can write your objective function, which is to minimize the total weighted percentage deviation, which will be, summation. Minimize total weighted percentage deviation. And here will be the W's times your DI's plus minus. Actually, you need different weight for the plus and the minus. I goes from 1 to 5. Okay, so this is not the correct representation. You need a different weight. Oh, sorry, let's just put plus or minus here. Okay, so this is just some analysis, and I'll ask you to finish this model and put on Moodle. So your question is, say, just treat those 70% one as a soft constraint? Yes. I probably won't do that, because here it says they want to make sure at least 70% is received. So like the purpose of a goal constraint, a goal programming is saying like, okay, it's desired to do something to get as close as something. We won't get less than 70% because we have to set those as a hard constraint. Say if you want to set those at least 70% as soft constraints, you may get less than 70%. Right. And remember, like the goal is to say, okay, we want to get close to a value. And here it's not saying, okay, it's okay to get close to it. We have to make at least 70%. Yeah, just think in a way like the goal is something desirable to do, but you can violate it. But for those constraints that cannot be violated, they need to be hard constraints. Okay, yeah, but one thing you can do is, besides setting, say, xi greater than or equal to 70% times the requested value, you can set, say, like the underachieving deviation need to be less than or equal to 30%. Does it make sense? Okay, so what I'm saying is, instead of having those ones, you can have like the DI underachieving ones less than or equal to the 0.3 times the target value. So as long as you not underachieve more than 30%, then you will get at least 70%. So these are two different ways to model. Okay. Any other questions?